Hello, welcome to Advanced Java Lesson 6. Today we'll be going over abstract classes, recursion, and we'll have a bit of work time to work with both topics. First, we'll be learning about abstract classes. Abstract classes cannot be initialized directly. You can think of them like blueprints for other classes. Other classes can inherit abstract classes, gaining their variables and methods. You might remember abstract methods from interfaces in Lesson 1. So this is one example of an abstract class where it can have a constructor, it can have variables, it can have methods, and then when another class wants to inherit from it, it should use extend, and it can use super to use the parent's constructor. In abstract classes, there can be two types of methods: concrete methods and abstract methods. Concrete methods are methods that are going to be actually defined and are either used or overridden by child classes. Abstract methods, as we saw in interfaces, are not implemented in the abstract class and therefore must be implemented in child classes. So for example, for this abstract class, over here, when the class dog extends the abstract class animal, it doesn't have to implement the concrete method sleep because it's already implemented, but it must implement the abstract method make sound. Now, I want you to go ahead and practice this. So create an abstract class car with instance variables color and year, and then go ahead and create these methods where honk is an abstract method and get info will print the info. Then go ahead and create these vehicles that extend car and add or override methods as necessary. In a runner class, go ahead and call get info and honk for all vehicles. So pause the video, work on that, and unpause when you're ready to continue. So this is one example of how you might have done this. So you can go ahead and create the string color, int year, and then go ahead and just use those in your constructor here. Then you create a abstract method called honk. Then you can go ahead and create this method get info, and you can just go ahead and put the contents of it, and then within SUV, which would extend car, you can go ahead and pass color and year to the super, so that would be the parent constructor, and then you don't need to declare get info because car already initialized that method, but you do need to do something with honk because it is an abstract method. And then you basically just do a very similar thing with the truck and the electric. Now in the runner, you can go ahead and do these, then you can get their info, you can get the honk, you can print it, and that's pretty much it. Next, we will talk about recursion. So recursion is when a method calls itself repeatedly. This can be used similarly to a loop in some cases. So the base case is the end condition, or what stops the recursion. This prevents the method from calling itself indefinitely, leading to a Stack Overflow error. This is so important because you do not want to ever really have something going on indefinitely and infinitely unless it's on purpose. The recursive step is the part of the method where it calls itself with a modified input, moving closer to the base case. So for example, over here for sum, you have your base case, which is going to be when n is less than or equal to 0, where you're just going to return 0. You're not returning some sort of function. And then otherwise, if it's not at that base case, you're going to return something that includes adding, subtracting, or doing something with the function of like another version of it. So in this case, we're returning n plus sum of n minus 1, which means it's going to call itself. It's going to do something, and it's just going to keep calling itself until it gets to the base case, and then it's going to work back and get your answer. So let's go ahead and go through this. So over here for factorial, we have our base case of n is equal to 0, where we return 1, and then before that we return n times factorial n minus 1. So let's try to work with that. So let's say we have factorial, let's say 4, so we're passing in 4. So immediately 4 is not equal to 0, so we go to else. And so we're saying we're returning 4 times factorial of n minus 1, which is 3. So now let's go see what factorial of 3 is. So if you pass 3 in here, it's not the base case. So now this is going to return 3 times factorial 2. Sorry, it's going to take me a minute to write this out. And then now we go back factorial 2. That's not the base case. So now that's going to be 2 times factorial 1. So now that's actually 2 times factorial 1. Once again, 1 is not the base case, so it's going to go one more time. So that's going to return 1 times factorial 0. And because factorial 0 is the base case, that's where we stop. We're not calling anything anymore. This is just going to be 1. So now we're going to work backward. We're saying that the sum, that whatever it's going to return is 1 times 1 times 2 times 3 and then times 4. So then that is going to be 24, which if you think about 4 factorial, that is 4 times 3 times 2 times 1. So let me quickly get out this drawing. But that is pretty much what recursion is, and it's super useful in some cases. It's not always going to be what you need to use, so just use it appropriately. Yeah, so recursion quiz, take a look at this and think about what is printed out, how many times is the method Fibonacci called, and what would be printed out if 6 was the input. Yeah, so over here, if you just go ahead and run this, what you're going to get is 0, 1, 1, 2, and then you can think separately for what would happen if 6 was the input. And when you're doing this, if you don't really get it from the start, really just like walk yourself through it, take it slow, and go through it as needed. So now that we've done this, we are going to move on to some recursion practice where you're going to write your own recursion. So I want you to go to Coding Bat Java Recursion -1 bunny ear, so you can just search this up, I think. So let's try searching that up. So we have Coding Bat Java Recursion -1 bunny ears. When you search this up, let's see, we're going to go to codingbat.com and you'll get here. So it's going to tell you instructions where we have a number of bunnies and each bunny has 2 big floppy ears, and we want to compute the total number of bunnies, the total number of ears across all the bunnies recursively without loops or multiplication. So we want to be able to run this recursively to be able to find the total number of bunnies. So try to think about what recursion method you can use for this. If you need hints, you can look at these hints, and then just work through it. What's really cool is that when you do Go, it shows you like the different things that you might be getting wrong or what test cases it might not be working with. So just go ahead and try that out, and when you're done, unpause the video. Okay, so this is a solution. So if your bunnies is equal to 0, this is going to be your base case. Then you return 0 because you don't have any bunny ears to add. There are no bunnies. Then otherwise, you're just going to return 2 for the current bunny plus the bunny ears of bunnies -1. After that, go ahead and move on to this recursion practice. So just pause the video, read over the instructions. Once again, you can just search this up online. I think it probably should be the second one again on codingbat.com, and then just try this out and see if you can do it. Yep, and then this is an example of what it will look like. So you have your base case as always, and then if it's going to be even, it's going to have 3 years, and if it's odd, then it's going to have 2 years. And the way you can find if it's even or odd is by using the modulus, which gets you the remainder. So if you're done with this, you can go ahead and add to your project, or if you want, you can also go back to the Coding Bat website, and if you go around, I think they should have so many more stuff, so you could practice change pi or something like that. So if you want, you can either go through, add more to your project, such as these examples: health upgrades, background, projectile types, more enemy types, or you can just practice your recursion more, and you can also explore other things that they have on the website. But that's it for lesson 6. Thank you for listening.